Hi everyone, welcome back to Master Engineer. In this tutorial, we have a beam with a span of 6 meters. The beam has a pin support at point A and a roller support at point B. It carries a UDL, a uniformly distributed load of 5 kN per meter, which is not acting perpendicular on the beam, but rather acting at 60 degrees. We need to find the support reactions, draw bending moment, and shear force diagram. To make life easier for ourselves, we could convert the UDL into point load. To do that, we will end up with two elements. The vertical element will be sine 60 multiplied by the 5 kN per meter of the UDL multiplied by the total length of the beam, which is 6 meters. And the horizontal element will be cosine 60 multiplied by the 5 kN per meter of the UDL multiplied by the total length of the beam, which is 6 meters. The element that contains the angle will be cosine 60, and the element that doesn't contain the angle will be sine 60. To find HA, the sum of all horizontal forces should equal 0. We have HA acting to the right, therefore positive, and we have positive cosine 60 multiplied by the 5 kN per meter of the UDL multiplied by the total length of the beam, which is 6 meters, equals 0. HA equal negative 15 kN. So that shows HA is actually acting to the left. We move on to find VB. To find VB, the sum of all vertical forces should be 0. We have positive VA acting upward. And then we have negative sine 60 multiplied by the 5 kN per meter of the UDL multiplied by the total length of the beam, which is 6 meters. And finally, positive VB acting upward. If you rearrange this, that will give us VA plus VB equal 15 multiplied by the square root of 3 kilonewton. Since we don't know the individual value of VA or VB, we call this equation number 1. We take a moment about A. The sum of all moments at A equals 0. We have the vertical component acting clockwise, therefore positive, and that is sine 60 multiplied by 5 multiplied by 6 multiplied by this distance, which is acting right here, 3 meters. Then we have negative VB acting anti-clockwise multiplied by the total length of 6 meters equals 0. If you rearrange this, VB equal 50 multiplied by square root of 3 divided by 2 kilonewton. Since we found the value for VB, we could substitute this into equation number 1. So we have VA, we put back the value of VB into here, which is 15 multiplied by square root of 3 divided by 2 equal 50 multiplied by square root of 3, which is here from equation number 1. If we rearrange all this, that will give us the value of VA equal 15 multiplied by square root of 3 divided by 2 kilonewton. Now we found all the reaction forces. We then move on to draw the shear force diagram and bending moment diagram. We start from point A. We have the reaction of 15 multiplied by square root of 3 divided by 2, and that's roughly 12.99 kilonewton. So that would be a straight line all the way to here. And then we have the UDL, which we found before, and that was sine 60 multiplied by 5 multiplied by 6, which was 50 multiplied by square root of 3. And then finally at point B, we have 15 square root of 3 divided by 2. That should take us back to 0. And finally, we move on to draw the bending moment diagram. Since the load is UDL and acting on the entire length of the beam with 2 support, we can use this formula to find the maximum bending moment value. WL squared divided by A, where W is the UDL, L is the entire length of the beam divided by A. The value for our UDL was sine 60 multiplied by 5 multiplied by the entire length of the beam, which is 6 meters to the power of 2. And the value we get is 45 multiplied by square root of 3 divided by 4, which is roughly about 19.48 kilonewton meter. And this is the value of the maximum bending moment. Now, if we draw the bending moment diagram, it would be a parabola because our load is UDL. And the maximum bending moment is around here, which is 45 multiplied by square root of 3 divided by 4. This is the end of this tutorial. Thanks for watching. Please remember to like, share, and subscribe to get the latest videos.